So when we have periods of time of low nutrient intake, then we stimulate this process called autophagy, or autophagy. Autophagy means to eat self, basically. So when we have damaged organelles or proteins, then we stimulate the production of what's called a phagophore, which is just a membrane that sort of forms a vesicle, and it will start to engulf damaged molecules inside of the cell. And it does this when we have low nutrient intake. It's like the body decides there's not enough energy to support all this garbage, so we better start cleaning it out. So let's get rid of all the stuff that we don't need, right? And then we can save the energy for the good cells. So we want to decrease our nutrient intake periodically so that we stimulate this cleaning process. Okay, so a phagophore forms, and then it will eventually engulf damaged cell components. Then it will merge with a lysosome. These are the organelles that have the digestive enzymes that will break down all of those cell components back into building blocks that can be recycled, and we can use those for other things. So how does the cell know what's damaged? We have these molecules, these enzymes in our cells called ubiquitin ligases, and these basically target damaged proteins and organelles. When they have this flag on them, then they are targeted for destruction. It is important to have periods of time when we're eating, because that's when we're taking in all the nutrients that we need to build our cells, to build proteins, to store energy for later. And this is basically our growth, our anabolic phase is when we're eating. When we're eating, we're making insulin. Insulin is our main storage molecule. When your blood sugar goes up, you produce insulin. It tells your body to store things for later so that you have energy when you're not eating. We also produce this molecule called mTOR. Bodybuilders and athletes love mTOR because this is the molecule that basically promotes protein synthesis. This is when you can build the most muscle. So we produce mTOR anytime that we are eating, when we have increased amounts of energy, especially if we're eating protein. So when we eat amino acids, stimulates mTOR. And this is why some athletes will eat like multiple times a day. It's to increase the amount of mTOR so they can increase the amount of muscle growth. When we produce insulin or mTOR, we stop the autophagy process. Okay, when we are fasting, this is our catabolic cleaning process. This is when we are going to produce glucagon, cortisol, growth hormone, thyroid hormones, right? Adrenaline, those molecules that help us to break down fat. Then we use the fat to make energy, or we use the fat to make glucose to keep our blood sugar stable. Then we also make a molecule called AMPK, and that inhibits mTOR. So we decrease the building and we increase the breaking down and cleaning out and recycling processes. When we look at AMPK, so this is adenosine monophosphate activated protein kinase. Basically, this is our energy molecule. Remember, we have 3 phosphates on an adenosine. When we chop off this last phosphate, we use that to bind to another protein, like your muscles, to make them contract. After we've used ATP, we produce AMP. AMP basically indicates to the cell that energy is decreased. Okay, so AMP is your energy sensor. So when you're having periods of time of not eating, AMPK will go up. And then what is it going to do? AMPK has lots of amazing functions. And remember, you don't make this when you're eating. We want to have periods of time when we're not eating so that we can make AMPK, and then this is going to decrease protein synthesis. It is going to stimulate processes like fatty acid oxidation so that we can break down stored fats and use those as energy or turn them into ketones or produce glucose. We will also stimulate mitochondrial biogenesis, so we will make more mitochondria. It will promote glucose uptake, so any blood sugar will get taken up by the cells, and then the blood sugar is going to start to decrease because you're not consuming food, so nothing is increasing it until your liver breaks down glycogen or converts some fats. Now, typically your blood sugar will go down to a certain point after you stop eating when you're fasting, and it will reach a low level and it will stay there. And it shouldn't dip down so low that you can't function. And I'll talk about those details. AMPK will promote the lipid metabolism so that we'll be able to break down fats. It also inhibits inflammation. And this is really important because a lot of people ask me, if I have chronic inflammation or if I have an autoimmune disease, can I still fast? And I say absolutely, because this is how we can actually decrease that overreacting immune response. We can decrease inflammation with fasting. And then AMPK is going to stimulate autophagy. It's going to stimulate that phagophore production where it engulfs the damaged organelles, and we're going to get rid of damaged things. It will inhibit mTOR, and it will also activate sirtuins. Sirtuins are really important for apoptosis. So autophagy is all about getting rid of damaged organelles. Apoptosis is about getting rid of damaged cells. And it will also promote the biogenesis of new lysosomes. And then apoptosis, this is going to help us get rid of damaged cells. So cancer cells, virus-infected cells, old cells that aren't functioning properly. So we want to have both of these processes. Sirtuins, think of these as our longevity molecules. Mice that don't produce sirtuins, if you make a sirtuin knockout mouse, they will age extremely quickly. The other important thing about sirtuins is that they help us repair DNA. So we accumulate DNA mutations for all kinds of reasons. When our cells replicate DNA, when we're exposed to toxins and free radicals and inflammatory cytokines, all kinds of things can impact our DNA, and we want to be able to repair DNA mutations. And sirtuins, that there's a whole family of these molecules, and they help us to repair damaged DNA. So, how do we increase sirtuins? They have a whole huge array of important functions, but I don't have time to go into that whole family of them right now. But basically, any of those hormesis things, cold exposure, heat exposure, exercise, low oxygen, and fasting will stimulate sirtuin production. And then also polyphenols. Polyphenols are super amazing molecules. Eat your colorful foods. They will help stimulate sirtuins that help you get rid of old, dead, damaged, cancerous, virus-infected cells. When we are going to fast, there's different ways of fasting, and I'll talk about the different types. But first, I want to address the issue of when you shouldn't fast, or who shouldn't fast. The number one reason to not fast is if you don't want to. Some people think that, they have to eat all the time or their blood sugar is going to go down and they're going to feel terrible and dizzy and they're going to faint and all of that stuff. And maybe people do feel that way, but there's a way to shift your body out of that. But if you don't want to fast, then don't fast. If people are doing intense physical exercise and they want to build muscle and they want all that mTOR, okay? Although there's a lot of arguments, that's a whole topic all by itself. Anybody that is starting a new exercise program, it will be difficult to fast because your body is going to be craving more energy because you've done something new that burns energy. Sometimes females will have a hard time in certain phases of the cycle. It is easier to fast before you ovulate. So after your period, before you ovulate, it tends to be easier to fast then, whereas the luteal phase, sometimes our hormones, that's when you're kind of getting ready for PMS and you're craving things. So it's just a little bit harder to fast. Pregnancy, because, you need to eat when you're hungry, you're growing a human. If you're younger than 16 years, then I don't recommend it, although most kids tend to fast naturally. Lots of times they'll skip a meal, they're not hungry. If they're not hungry, then they don't have to eat, and they'll eat when they're hungry. And then anybody that is recovering from a major illness or surgery or injury, you need more protein and you need to ensure that you're building up. So those are my suggestions for when you shouldn't fast. Oh, I want to point out that when you're sick, okay, so have you heard the expression, starve a fever and feed a cold? Sometimes when you're sick, you're starving, and then your body wants you to eat all kinds of nutrients. And sometimes you have no appetite at all. Listen to your body. It normally knows what it needs. So if you are not hungry, then your body wants to go through autophagy, and it wants to increase apoptosis and kill virus-infected cells. So if you're not hungry, don't eat. Listen to your body. If you are starving, then eat. Your body needs the nutrients to fight the infection.